Okay, so this one here, you want to prove true for n equals 1. So n equals 1 is just like adding that first term there. Now, when I look at that, I can see straight away it doesn't work, so I go back and I check. It's actually not for n equals 1, you want to do it for 2. That's the first one that you do. So the first term, which is the left-hand side, will be 1 on 2 squared. And also, if you use the Tn rule for any term, that would be when n is 2, so that would be 2 squared. So the first term is summing it from when n equals 2, equals a quarter. And if you look at the right-hand side, now, the right-hand side, when that's equal to a quarter, the right-hand side will be, let's have a look at that, 2 minus 1 on 2, which is a half on 2, and a quarter is less than a half, so therefore it's true when n equals 2, not 1, 2. Okay, so what we're going to do is going to assume for n equals k, so that's 1 on 2 squared plus 1 on 3 squared plus 1 on k squared is less than k minus 1 on k. I'm going to prove for n equals k plus 1. So you're required to prove that 1 on 2 squared plus 1 on 3 squared plus 1 on k squared plus 1 on k plus 1 squared is less than. Now if you put a k plus 1 in place of that k, let's say k plus 1 minus 1, that's this one, all over k plus 1. So they cancel, so it's k on k plus 1. That's what you're trying to show, that it's less. Okay, so what we need to do is we always, if we start with n equals k, and then we create a middle term. So we create a middle, and the middle we call b. So this first thing here, from there to there, that's a. That's the sum of k plus 1. This k on k plus 1, we call that c. So we're going to create a middle term, which is a b, but we're going to start with this. 1 on 2 squared plus 1 on 3 squared plus 1 on k squared is less than k minus 1 on k. Now, if I want to create that right-hand side, the only extra thing it has is if I add in 1 on k plus 1 squared. Now, if I do that to the left-hand side, I need to do it to the right-hand side, otherwise it's actually going to change the expression. So this here now, this is a, and we're proving that we know that a is less than this, and we call that b. So what we need to do is prove that b is less than c. And if a is less than b, which is less than c, then a will be less than c. Okay, so what we're going to do is we're going to prove that b is less than c. And then if this is true, then a will be less than b. That's what we know from our assumption. And then if that's less than c, then a will be less than c. That's the method of our proof. Okay, so what we're required to prove is that b is less than c. So that would be k minus 1 on k plus 1 on k plus 1 squared is less than k on k plus 1. Okay, so in order to prove that, let's bring them all over to the one side. I might bring that over to there. So k on k plus 1 minus k minus 1 on k minus 1 on k plus 1 squared. Now we're proving that that is greater than 0. So let's get a common denominator, which is k plus 1 squared. And then we notice that here we need to multiply by k plus 1. This one we need to multiply by k plus 1 squared. And this one here just by k. Okay, so on the bottom, that's k plus 1 squared, k squared plus k, that's from there, minus k minus 1 times k squared plus 2k plus 1 minus k. Okay, so first of all, these k's will go out. I've got to expand the top line of that bracket, and then I'm just showing that this is positive. So expanding that top line, k squared minus, now we go k cubed, that's to there, plus 2k squared plus k, and then minus k squared minus 2k minus 1. That is all over k plus 1 squared. Okay, so we're trying to prove that this is positive, so let's just keep going with this. So get k squared minus k cubed minus 2k squared plus k minus k squared will be plus k squared, and this one will be minus, plus 2k plus 1 all over k plus 1 squared. Okay, things that cancel out. We have k squared minus 2k squared. We have minus k plus k, which gives you k. So we have k cubed plus k plus 1 all over k plus 1 squared. Now, n is greater or equal to 2, so k must be greater or equal to 2. So k cubed is greater or equal to 0, because k is greater than or equal to 2. K is greater or equal to 0 because of the same reason. So that whole top line there is positive. The bottom is positive as well. So therefore the whole thing is greater than or equal to 0. So it's true. So therefore, because that's true, B is less than C, but A is less than B, which is less than C. Therefore, A would be less than B. Okay, so B is less than C. That's k minus 1 on k plus 1 on k plus 1 squared is less than k on k plus 1. And A is less than B, which is less than C. So that would be 1 on 2 squared plus 1 on k plus 1 squared. Like the sum to k is less than whatever that B is just here, which is less than k on k plus 1. So therefore, 1 on 2 squared plus 1 on k plus 1 squared is less than k on k plus 1 as required. Therefore, by the process of mathematical induction, true for all integer n greater than or equal to